For questions 1 through 12, I'm going to refer to y equals mx plus b, or f of x equals mx plus b, where m is the slope given by this formula and the y value of the y-intercept is b. So I'm also going to, as I work along here, just check my work on my calculator. I have it next to me. So I wanted to sketch a graph of f of x equals x minus 7. I know that the slope is the number in front of the x, which is 1. So the slope is 1, or if you want it as a fraction, 1 over 1. B is negative 7, meaning 0 comma negative 7 is the y-intercept. And with this information, I have this as my graph. Here is 0, negative 7, the y-intercept. The slope is 1, meaning I go over 1 and up 1. And the second you get a second point, that's really enough to sketch your graph. So I'll type that into my calculator, sketch what I see on my screen. Again, just a reasonable sketch. And that is it. Well, actually, there's one other thing I did put in the directions here where, okay, this is the y-intercept. Slope is 1. I go over 1 and up 1. But there's also an x-intercept on my graph, which I'll put over here. I can actually see from my graph on the calculator that it does go through 7. So in terms of the x-intercept, I know it's the point 7 comma 0. If you did not know that, you can use this equation to solve for it very easily. You take your equation, you set it equal to 0, and then you solve for x. In this case, you would just add 7 to both sides. The x value is 7, the y value is always going to be 0, and that's it for question 1. For question 2, g of x, doesn't matter if I use the letter g instead of f, but g of x is equal to 1/2 x plus 4. The slope is 1/2. And the y-intercept, b is 4. I think I'll just put 0 comma 4 is the y-intercept. So for my graph, here's 4 on the y-axis. The slope is over 1 and up 2. And my graph is the line going between those 2 points. And I'll just check it on my calculator. Okay, that looks good. All right, great. So I know the slope, I know the y-intercept, but what's the x-intercept? Again, my sketch could be off because I'm not really using a straight edge. So for the x-intercept, I'm going to go to my equation, which is 1/2 x plus 4. I'm going to set it equal to 0 and solve for x. After I subtract 4 from both sides, I get 1/2 of x is equal to negative 4. Multiplying both sides of this equation by 2 gives me x is equal to negative 8. So that is in fact this location right here. So you could say, not just negative 8, but it's the point negative 8 comma 0 is the x-intercept. Maybe just going back up to the very first problem, I could have more accurately said 7 comma 0 is the x-intercept. For question 3, the slope is negative 2/3. And the y-intercept is 0, negative 5. So I start here at negative 5. I go over 3 and down 2 to get a second point on my graph, and I'll sketch the line that goes between them. There is my sketch. If I now want to find the x-intercept, whatever that is, I take my equation, I set it equal to 0. I'm saying the y value is 0, so what is x equal to? I will add 5 to both sides. So I added 5 here on the left and the right. I'm now going to multiply both sides by negative 3/2. So on the left, I'm multiplying that to negative 2/3 x. On the right, I'm multiplying that to a positive 5. The value comes out to be x on the left, and on the right, I have negative 15/2. And I kind of want to change that to a decimal and check it in my calculator on the equation I plugged in. So, my sketch, definitely off a little bit, but I get negative 7.5 for the x value. So the x-intercept, if I check that in my table, my graph looks good, and it works. So x-intercept, y-intercept, and the slope. Okay, for the next function, k of x is equal to 5x plus 1. The slope is 5, or 5 over 1. The y-intercept is at 0, 1. So let's see, here's 0, 1. The slope of 5 means I go over 1 and up 5. That's a fairly steep line, but it goes between those 2 points. And here, I can see the x-intercept is something between 0 and 1. So to solve for my x-intercept, same idea, just set my equation equal to 0, subtract 1, and divide both sides by 5, giving me my answer of x is equal to -1/5. That's the point, -1/5, comma 0 as my x-intercept. For question 5, the function t of x equals -3x plus 9. Getting real clever with the names for my functions. The slope here is, okay, it's -3 or -3 over 1, and my y-intercept is 0, 9. That means I'm way up here. For my y-intercept, I'm going down 3 and over 1 to get the second point here, and my equation is going between those 2 points. So there's my sketch. It looks way better on my calculator, but I want to find the x-intercept, and boy, it kind of looks like it's located at 3. Let's see. Is that the location of my x-intercept? Again, that is the x value when my y value is 0. I guess I'll subtract 9, and I have -3x is equal to -9. Dividing both sides by -3 gives me x is equal to +3. That is 3, 0 for the x-intercept. For number 6, the function is L of x is equal to 7, and I put this 0x in here just to kind of really point out that the slope is in fact 0, because 0 times x is 0, and we don't have to write it in our equation. So if you don't see a variable x, it means your slope is 0, or even 0 over 1 if you'd like. The y-intercept is 7, and this is our way of saying that we have a horizontal line. We get 0, 7 for the y-intercept. I go over 1 and up 0, down 0, doesn't matter. This is horizontal, going forever in both directions. And I already know that from this graph, there is definitely no x-intercept. It is parallel to the x-axis, meaning that it'll never intersect it. But you could, if you wanted to, take your equation, as I wrote it, 0x plus 7, and set it equal to 0. But this simplifies to 7 equals 0, and well, that's not true, that's false. And this is another way of saying there is no solution to this equation, or there is no x-intercept. For questions 7 through 12, now we're going to start finding the equation of a line that goes through the given points. And you can still check this in your calculator too. You can enter in your equation and then check in the table if your points both work. So the way I labeled this was, for slope, I'll call this one x1, y1, this other one x2, y2, and when I compute the slope, it's the difference of the y values, so y2 minus y1, over x2 minus x1. And this simplifies to -4 over +4, or simply just -1. Now you could put f of x, I'm gonna, I guess for these, choose to write it as y. There isn't too much of a difference, but I'll write all of my equations in this form. Let's see, okay. All I know up to this point is that the slope is -1, so I'll go to my equation and put -1 in place of m, and just note that I don't know b. I'm not actually going to write the 1 because -x does mean -1x. The last step is to find b, and you can use either of these points to do so. So I'm just going to pick one at random. I guess I'll go with this one here. I'll put 4 in place of x and 0 in place of y. I just won't know b, meaning I can solve for it. Y is equal to 0, x is equal to 4. When I solve for b, I'm adding 4 to both sides of my equation, and here we go. B is equal to 4, and this means I have my equation. I know the slope, and I know the y value of the y-intercept. And you now can plug this into your calculator and check to see if both points work in your table. For 8, I'm going to do negative 17 minus a negative 2 over 4 minus a negative 1. This is negative 15 over 5, and this is equal to negative 3. I'll put that into my formula as negative 3x plus b. I guess I'll use this point in place of x and y. This gives me negative 2 is equal to negative 3 times negative 1 plus b, or negative 2 is equal to 3 plus b. After subtracting 3 from both sides, I get that b is equal to negative 5. My equation is y is equal to negative 3x minus 5. For question 9, the slope, I wrote it as, okay, we get 4 minus 4 over 100 minus a negative 10. And this one simplifies nicely. We get 0 over, well, that's 110, but really that's just 0. And as we've seen before, a slope of 0 means we have a horizontal line. At this point, I can just jump to the answer of, well, the y value is 4. I know it's just going to be y is equal to 4. But just to check it out, I'm going to go through the process of taking my equation, putting 0 in place of the slope, and then using one of my points to solve for b. If I use this point, I put 4 in place of y and negative 10 in place of x, and I simplify this to b is equal to 4. Therefore, my equation is equal to 0x plus 4, but really this just simplifies to y is equal to 4. Okay, so for question 10, I chose my 2 points in this order. Can I actually find a function y equals mx plus b that goes through those 2 points? I feel like something weird is going to happen here, but let's check it out. Okay, this is y2 minus y1 all over x2 minus x1. When I simplify this, I get negative 1 plus 5 is 4 over negative 7 plus 7, which is 0. If you type in 4 divided by 0, or really any number divided by 0, it's going to give you an error message. Yeah, it says error, divide by 0. So that means you can't actually do this. We can go no further in this process. Since there's no slope, it's undefined, and we are unable to write it in this form. However, there is a way to express this equation, it's just not a function. In our previous example, if the y value is always the same, the answer is just going to be y is equal to that number, 4. Analogously, in this problem, the x value is the same for 2 different points. So that means the answer is going to be x is equal to negative 7. This is a vertical line at negative 7 for x, which is why it can't be written as a function. For question 11, going back to, I don't see anything funny happening in this one. I think we can find an equation going between those 2 points. I'll do 9 minus 6 as my y2 minus y1, and then 4 minus negative 8 as x2 minus x1. 9 minus 6 is 3. That's 4 plus 8, which is 12, and this is 1/4. You could write this as a decimal, but I kind of like thinking of slope in terms of a fraction because it tells me like how things are increasing and decreasing. I think it shouldn't be a problem for this particular question, but let's try it out. Y is equal to 1/4 x plus b. And I'm going to choose this point because x is equal to 4, and if I put 4 here, 4 times a 4th is just 1. It simplifies really nicely. So let's do that. 9 goes in place of y, 4 goes in place of x, and as I said, 1/4 times 4 is 1. To solve for b, I can just subtract 1 from both sides, and that gives me 8. This is my equation. Y is equal to 1/4 x plus 8. And lastly, for 12, I threw in a question that just had a couple of decimals in it. We should still be able to approach this the same way, where The way I set it up, it's 3.82 minus 3.4 divided by 0.27 minus 0.9. I don't know about this one. Let's see, m is equal to 3.82 minus 3.4. That's 0.42, all right? And then we have 0.27 minus 0.9, and that's negative 0.63. I think this is going to be kind of a mess, but let's see. I'm going to divide this out in my calculator. That's actually not too bad. Okay, this slope, it's a negative number, and I did 0.42 divided by 0.63, and that's simplified to 2/3. So that is the slope of the line between these 2 points. All right, let's see, y is equal to negative 2/3 x plus b. And now I have to solve for b by using either one of my points. I guess I'll use the first one here. 0.9 goes in place of x and 3.4 goes in place of y. 3.4 is equal to negative 2/3 times 0.9 plus b. All right, so we have 3.4 is equal to, the answer is going to be negative on the right here. Well, 3 goes into 0.9 0.3 times, and then I'm going to multiply that by 2, which gives me 0.6. So this is negative 0.6 plus b. Excellent. Now add 0.6 to both sides, and it takes me to 4 for b. My answer is y is equal to negative 2/3 x plus 4. For questions 13 through 18, we're going to be solving some linear equations. The strategy for it is fairly straightforward, where we add, subtract, multiply, and divide things to both sides. So I'm going to move all the x's to the left and the numbers to the right. I see there's this negative 4x here. I guess I will add 4x. This gives me 6x plus 19 is equal to 1. I can then subtract 19 from both sides, and I get 6x is equal to negative 18. After I divide both sides by 6, and I've isolated x by itself, I have negative 3 as my answer. For question 14, the only thing with linear equations is potentially you'll have to just have some more steps after you distribute, cancel fractions, or something like that. So for this one, I'm first going to simplify both sides. I'll distribute this negative into the parentheses as well as this positive 2, and this changes my equation to negative 1 plus 3x plus 6 is equal to 4 plus 2x plus 2. I can now combine like terms on the left and the right, so I get 3x plus 5 is equal to 2x plus 6. And now the equation here, it's a similar idea of what we have here, where I'll move the x's to the one side, the numbers to the other. So you can even do this in one step if you'd like to. I know I'm going to subtract 2x from both sides, but why not at the same time say, okay, I'll subtract 5 from both sides. There's nothing wrong with doing that. This will give you x on the left and 1 on the right, and 1 is the solution to this equation. So for question 15, again, solving this linear equation, there is a trick if you'd like to cancel off your denominators, and that is to multiply both sides by the least common denominator of, in this case, 6, 3, and 2. I know that you can multiply all of those to get to 6, so 6 is the least common denominator. If I multiply that to the left and to the right, it'll cancel all of those numbers. Multiplying it to the left means I multiply it to each term, and on the right, it just gets multiplied here since there's only one term. That is, I multiply by 6, or 6 over 1 to the first part, then 6 over 1 to the next part, and then 6 over 1 on the other side. This is what it looks like to multiply both sides by the same number. And we did this because you can now cancel factors between the denominator and the numerator. 6 goes into itself once. It completely canceled there. 3 also goes into 6 with 2 left over. And 2 goes into 6 3 times. Here's what we have. I'm going to write this as 1 times x plus 1. That's because the 6 is canceled with just 1 left over. Then we had plus, okay, this is just 2 times 1 divided by 1, so that's just 2. And on the other side, we have 3 times x minus 1. Be careful that after you cancel these, this 3 is being multiplied to this whole thing, which is why I included parentheses. Notice that I did the same thing here, although in retrospect, this was not necessary. I mean, this 1 when multiplied in doesn't change anything, so I'm just going to write that as x plus 1. I still have this plus 2, and if I distribute the 3, I get 3x minus 3. So this is x plus 3 is equal to 3x minus 3. I suppose I'll subtract x from both sides, yet at the same time, add 3 to both sides. This gives me 6 is equal to 2x. If I divide both sides by 2, this gives me my answer of 3 is equal to x. Same idea for question 16, where I'd like to cancel all of the denominators, and our denominators are 5 and 2, so the least common denominator is going to be the product of those two numbers, 10. If I multiply 10 to both sides of this equation, I put a 10 over 1 here, 10 over 1 here. You could actually just write 10 here since you don't have to deal with any fractions. You could put 10 over 1 if you'd like, but then I'll put 10 over 1 for the last piece. 10 worked perfectly because 5 goes into it twice, 2 goes into it 5 times, and 2 goes into this 5 times as well. Here's what we have left over. 2 times 2x, which is really 4x, minus 5 times x, or just 5x. And then I have 10 times, okay, it's 5 times 3x, so that's plus 15x. 4x minus 5x is negative x, which is equal to 10 plus 15x. I think next what I'm going to do here is, I'm going to do something backwards, I guess. I'm going to go take the 15x from both sides, which gives me negative 16x is equal to 10. So now I can just divide both sides by negative 16, and my answer becomes x is equal to negative 10/16. There's a factor of 2 I can cancel. That's 5/8. So what I did there is, oh right, 10 divided by 2 is 5, 16 divided by 2 is 8. The negative you can write in front of the expression, and that's the answer. So if you don't like working with decimals, then you can always cancel them just like we canceled fractions by getting rid of the denominator. So if I examine this expression, if I can move the decimal point 2 places this way and 2 places this way, it would change this to a 1 or simply just x, and this would become 3. Here you only have to move the decimal point once, but to multiply something to both sides means the decimal point has to move the same on every single amount. What I'm going to do is multiply both sides by 100. That will move the decimal point twice here, twice here. It also moves it 2 times here, but who cares? It'll be 10. It still won't be a decimal. Here's what we end up with. 1x, which is just x. The 0.1 becomes 10. That 0.03 becomes a 3. And we just got rid of the decimals from this problem, making it a relatively easy linear equation. I'll distribute in the 3. So x plus 10 is equal to 3x plus 21. I guess I'll subtract x and also subtract 21. So I get negative 11 is equal to 2x. And so dividing both sides by 2 gives me my answer of negative 5.5. So for this problem, I want to cancel the 1/2 So that means I'm going to multiply both sides of this equation by 2, meaning I'm just doubling this 2, this 3, this 1, and doubling this changes it to a 1, which means I don't even need to write the parentheses either. All of that being said, I get 4 times x minus 4 plus 6 times 2x minus 8 plus 2 is equal to 4x plus 22. I doubled all the terms, and on the very last one, it was a 1 in front of the parentheses, so I just, chose not to write the parentheses. I'll next distribute in the 4 and the 6. We get 4x minus 16 plus 12x minus 48 plus 2 is equal to 4x plus 22, okay? Combining like terms on the left, I get a 4x and a 12x, which is a 16x. Negative 16 minus 48 plus 2 is negative 62, and that's equal to 4x plus 22. I'm going to choose to subtract 4x from both sides, and then I guess add 62 to both sides, leaving me with 12x is equal to 84. And if I divide both sides by 12, I get my answer of x is 7. For 19, I see that the place where the two graphs are equal is right here at 2, 2. In fact, I'm just going to mark down the x value where that happens, 2. I'm also going to label my functions. Okay, f of x is going to be the one with the negative slope. So here is f of x, negative 3x plus 8, versus g of x, which has the positive slope. And this question is asking for, when is f of x greater than g of x? There's no other work for this problem other than to look at your graph and then record down the x values for which this happens. Here's f of x, and then here's g of x. If you choose x values over here, f of x is actually lower than g of x. This means that 2 to infinity is not the solution. If I check everything that is less than 2, here is f of x, here is g of x, and f of x is definitely greater than g of x on this side of 2. So this means my answer is x is less than 2, and if you'd like to use an interval, that is everything from negative infinity to 2. For question 20, I want to figure out where f of x is greater than or equal to g of x. So let's again correctly label our functions. They both have a negative slope, but g of x is definitely a steeper decrease than f of x. So for this reason, this is g of x. It has a slope of negative 4 and also a y-intercept of negative 12. And then this one, f of x, has a slope of negative 0.5 or negative 1/2. I see that they intersect at negative 4, so we're left deciding, where is f of x greater than g of x? On this side of negative 4 or on this side of negative 4? So let's see, this is f of x. F of x is above g of x. Here's f of x. It's always above g of x, and that means my answer is everything from 4, including negative 4, to positive infinity. So you could say x is greater than or equal to negative 4, or as an interval, negative 4 to infinity. For f of x is less than g of x, again, I see these two graphs meet here, and that's at 3. So whatever the answer is, it's got to be either less than 3 or greater than 3. Let's see. G of x itself is 3, and that means it's the horizontal line. So here's g of x. Whereas f of x has a slope of positive 8, so clearly the blue one is f of x. So where is f of x lower than g of x? Here's g of x. Here's f of x. It's definitely this portion of the graph that is lower than g. These are all the x values going from 3 to negative infinity. So you could express the answer as x is less than 3, or as an interval, negative infinity to 3. For 22, I can see these two graphs intersect here, and that's at x is equal to 10. So again, our answer is either to the left of 10 or to the right of 10, including it this time. And let's see, the slopes of both f and g are positive, but f of x is less of a slope than g of x. So therefore, f of x has to be the blue line. So this is f of x, and then this is g of x. So where is f of x lower than g of x? It's not over here because we're above the function g, so it's not this stuff. Over here, this is where f of x is lower than g of x. The corresponding x values go from 10 to infinity. So again, you could write x is greater than or equal to 10, or as an interval, everything from 10 to infinity, both answers are acceptable. In questions 23 through 28, I just wanted to show you a situation where something strange could happen when you solve an equation. So going back to solving this thing for x, I'm going to distribute the negative. We get 2x plus 1 is equal to x minus 4 plus x. So that is 2x plus 1 is equal to 2x minus 4. So here's the issue. When you go to solve this for x, you'd have to subtract 2x from both sides, and you could even stop right here. You get 1 on the left, negative 4 on the right, and this is false. Those two things are not equal. If you encounter something like this within an equation, all of your steps are valid, and you wind up at a false statement, it means none of the previous ones can be true. In this instance, we will say that there is no solution. There is no number that makes this thing true. Now, if you compare this to the inequality where I put a less than in this problem, let's approach it the same way where I'll distribute the negative and combine some like terms. So 2x plus 1 is less than x minus 4 plus x, or simply 2x plus 1 is less than 2x minus 4. It's okay to subtract the same thing from both sides, and you get 1 is less than negative 4. And in this problem, again, we have something false. 1 is definitely not less than negative 4. Since this is false, we again have this situation where there is no solution. You could also look at a graph to support your answer, but I think this is good enough here where if you're working with an equal sign and you have two things that don't equal each other, it just means that there's no solution. If you're dealing with an inequality, and again you arrive at a false statement, it means there is no solution. Let's try this one out. I'll distribute the 2. See if anything weird happens in this problem. We get negative 3x plus 2x times 8 is equal to 10x plus 12 minus 11x. Okay, so if I simplify the left, I get negative x plus 8 is equal to negative x plus 12. If I add x to both sides, I get 8 on the left and 12 on the right. Again, this is false, and so this means no solution. We can pretty much stop right there. This did not work. Now, if we compare this to, in question 26, what I have less than or equal to, so almost the same thing, but just less than or equal to. If I go to solve this one for x, it'll look very similar. So we get negative 3x plus 2x plus 8 is less than or equal to, okay, we get negative x plus 12. So that is negative x plus 8 is less than or equal to negative x plus 12. I will, I guess, add x to both sides, and I get 8 is less than or equal to 12. Now this is actually very different than questions 23 and 24. If we look at this one, they're not equal, but with respect to the inequality, it is true that 8 is less than or equal. I mean, it's not equal, but it's definitely less than 12. This is always true. And that means everything is a solution. The solution is all real numbers. That's very different than up here. Like up here, they were different, no solution. Here, we had something that is always true. It means that every previous step is always true as well. No matter what number you pick and you put it in place of all these x's, it would always simplify to 8 is less than or equal to 12, which is always true. All right, let's check this out is there another possibility than the 4 previous questions? I'll distribute the negative and try to solve for x, and we get 6x minus 4 minus 5x plus 1 is equal to x minus 3. So when I simplify, I get x minus 3 is equal to x minus 3. And both sides are identical. So like you could subtract x from both sides, yet you could add 3 to both sides if you wanted to go this far, but what you end up with is 0 is equal to 0, and that's true. In fact, it's always true. So what that means is the solution is all real numbers. So it's possible that even if you have an equal sign, that the answer could be all real numbers if it reduces to exactly the same number on the left as you have on the right. Now let's compare that to the one with the inequality. So same idea, where in 28 you have 6x minus 4 plus 5x plus 1 is greater than x minus 3. Is the answer going to be all real numbers too? Let's see. I distribute the negative. I get 6x minus 4 minus 5x plus 1 is greater than x minus 3. So, right, I mean, this is all coming out to be the same thing, right? It's x minus 3 is greater than x minus 3. You could, again, subtract x from both sides if you wanted to, and then I guess also add 3 to both sides. And you do end up with that 0 on the left and a 0 on the right, but you get greater than. And no, 0 is equal to 0. This is always false. In fact, or you could just say false. That means there's no solution. By the way, had I put greater than or equal to in this question, like just for sake of argument, if it was greater than or equal to, then you would have an equals down here, and it would always be true again, meaning that everything was a solution. So you just have to be a little bit careful at what the answer turns out to be. But at least for this problem, there was no solution because 0 is not greater than 0. That is a false statement.